Hello and welcome to this walkthrough of creating a package to process differential Brightspace dataset files. In this example, we're using SQL Server data tools based on a SQL Server database where we're storing our data. You may find that you use different tools for this process, but the logic will still be roughly the same. So in this case, I've already set up the beginnings of data flow task. I've set a flat file source and an OLDB source. In this case, the OLDB source is pointing to the specific table that we're using, content user progress, for this example. And the flat file source is pointing at a differential file that I have downloaded from Brightspace and would like to update in my database. So the differential files, as I'm sure you're aware, are the changes made between the previous data set and over the time period that it encompasses. So you'll need to insert new rows and update the current rows that are in there that have any updates. And many rows may not be touched on a day-to-day basis. So it's important when you're designing this tool to keep that in mind, that you don't want to dump all the data, but you also want to perform this as efficiently as possible. So you'll want to set these up for yourself. This may take a little time just based on where you've stored things or getting the data to be ready. Important is that in the flat file source, you specify what the data types are. You can use the admin guide to help you with these dataset types. But if you already have a database up and running, you're probably already familiar with it, and you'll want to match exactly what's in your database. You won't have a problem initially if you set that up incorrectly, but later on in the flow, you'll start getting errors if your data types are not correct. So our next step here is that we'll eventually want to do a merge join, but before we get into a merge join, we need to use the sort tool in order to sort things properly before we pull them into the merge join. So you'll need to sort both data sets. So just pull two tools right out here and feed each data set into one of the tools. So this tool is doing what you might expect. You can just select certain columns and it will sort them. In this case, we're using content user progress, so you'll want to sort by the primary key. In this case, it's a composite primary key using the content object ID and the user ID. So I've just selected content object ID first, user ID second, and using the default values here. As long as you're consistent between the two, it doesn't really matter how you sort the primary keys. There we go. Okay, that's all set. The next tool that we're going to want to use is the merge join, which is located right here. So the merge join it basically operates like a join in a relational database. You're taking your output from the sort, and you're going to define which side it's going to come in the merge join. So in this case, I'm setting the flat file as the left input, and I recommend that you do the same if you're following along. And then this database source default becomes the right input. So if we open this up, you can see that our join keys are identified correctly based on the sort. And we have to specify what type of join we want. In this case, we want the left outer join. Because we have set the flat file as or the differential file as our left side input. You'll want to include all of the differential file and only those entries in the database that are also in the differential file. You don't need to update any of the rows that are not in the differential file, is basically what we're getting at here. So you'll want to include all the fields from the file, and just one of the fields, one of the primary key fields from the database table. And in this case, I'm just going to alias it so it's a little bit clearer later on that this is not column that needs to be inputted back into the database. This is just sort of a flag to say, is this a new insert or is this a row that needs to be updated? If it already exists in the database, it needs to be updated, and if it doesn't, if this column is null, then it can just be inserted. So we're going to hit OK here. And so now that we have sort of this result, we need to split it out because we're going to treat the inserts and the updates differently. And this is also the place that if you were going to use the deletes to remove rows from your database, you would also be splitting them out here as well. So we're going to do that using a conditional split tool. There it is. Just drag it down here. And then pull from your merge join into the conditional split tool. So the conditional split lets you set up sort of an expression in which you want to split your data set on. So we're going to have two explicit outputs, one called new rows and one called updated rows. And we will want to use that join ID that we specified before. And we're just going to check if it's null. And if it is null, then it is new entry, and we'll just need to insert it. And if it is not null, then it's an update, and we will have to update it. So our conditions are pretty simple in this case. You may have a situation where you have much more complex conditions or many more conditions, or perhaps just one condition and everything else grouped into other. But this is what we have for this situation. Okay. The next step is, now that we have our two outputs, we need to pull them in, sort of treat them so that we can insert them back into the database. So one of them, the inserts, we can sort of easily insert right back into the database. That's relatively simple. So you bring your OLE DB destination. If you remember, we pulled from an OLE DB source. So if you use something different, you'll want to use the same equivalent here. We'll want to specify that we're taking the new rows and putting them in here. So it should default to the same connection manager that you used before. And that should be correct. You should be wanting to put it right back in that same table. So just select the table from your list of tables, and helps to double check over on mappings that you've got everything mapped correctly. Everything's looking good here. You'll notice the join ID isn't mapped, and that's correct because the join ID is unnecessary in the final table. We just needed to determine if it was a new row or an updated row. So great, inserts are done. That should go straight back into the database. And now we need to deal with the updating rows. So this is a little tricky, and here's where it goes. You'll have to refer to the text that accompanies this video. Is that you'll need to build a stored procedure that performs the updating function and basically matches based on the primary key of the specific table and updates all the columns to the new values that are coming from this conditional split. So write a stored procedure, store it in your database. You could even make it more complex than that and only update the ones that have changed, or to keep a history table, if you'd like, of the changes over time. But in this case, I just wrote a pretty simple stored procedure that is just going to update all of the rows. So again, because we're using an OLE DB source, I need to pull an OLE DB command tool type. And you need to pull in the correct output, which in this case is the updated rows. Okay, so first you'll need to choose the correct connection manager. It again should be your same database that you're working with all the way through. And what you'll need to do is come in here into the component properties tab, and where it says SQL command, you'll want to call your stored procedure. So I have it over here in another window. Let me copy paste. And again, this simple stored procedure is just taking all the column inputs from here, this package, and then finding that matching based on the primary key in the table and updating all the other columns appropriately. So pretty straightforward process there. Again, you want to make sure that all of your columns match. And again, you're not going to want to pull that join ID over. The join ID at this point is unnecessary for the process. Okay. And here's where you might see some issues if your inputs and outputs are not correct. And there we go. That's it. So coming from both your flat file differential and your current database table, we have sorted both sources so that we can properly merge join them. And then taking that combined result, we've split them out into both new rows and updated rows, and then fed them both back into the database. So once you run this package, you would then have that table updated to include all the information, relevant information in that differential file. And that's the logic that you would need in a package that would process differential files using an upsert.